Okay, so let's go ahead and just do like a really quick Slack demo. See if I can take this one. Yeah. All right. You guys see that all right? All right, cool. So this is our Slack channel. So you guys have been using it already a little bit for today and to add your homework assignments to it. But I just wanted to do like a quick review to make sure that you guys understand how to use it and like what Slack is. Slack's used by most like industry corporate organizations. So you're probably, once you're graduated and working in your career, you're probably going to be using Slack anyway. So I think it's a good time to kind of introduce you guys to it anyway. So over on the left-hand side, these are all my kind of work areas. And the one that we're in is the QC design group. And then in that, there's channels, and then you could do direct messaging too. So the channels are, I have private channels. Those are the ones that have a lock on it. And the public channels have a little hashtag symbol or number sign next to it. So I've been using Slack for my classes for the last like year and a half, 2 years. And all of my students are a part of this group. So like past and current. So anyone that has been in any of my classes for the last 3 or 4 semesters is still attached to this. So if you go to general, you can see that there's 185 members that are a part of this channel and group. And general, it just allows you to communicate with anyone. So anyone that's taken my class in the last 3 semesters or in any of my other 2 classes as well. So if you wanted to like get feedback, general feedback on your projects from, you know, more people than just our small class of 17, 16, then feel free to use the general channel. There's also a random channel if you just wanted to add like random information or things that you think are cool, you can add that there too. But for our class, it's going to be mainly we're going to be using the PComp Fall 2021 channel, which is a private channel. So it's only going to be visible for anyone that's a part of this class. So this is the channel that we're going to be mainly using and for class time and share homework and share your assignments and just have general conversations both in class and out of class. So very simple at the bottom. Here's a message area that you can type messages. You can do simple things like doing bold or italic or strike through, stuff like that, and then hit send now, and then that's going to pop up there. Tony's having some issues getting into Zoom. Okay, so and then I was talking about threads. So threads are great because you can, like if you submit a project or assignment on Slack, then we can add create a thread attached to it with comments and ideas and feedback. So if we wanted to thread this, then if you hover over the message, then you get this option on this menu bar on the right-hand side. And you can add a reaction. Some of you are already doing that, which is just like a little, icon or emoticon. Then there's threading. So it allows you to create a thread. And then you can basically kind of keep organized with your conversation about any one particular topic that was shared with the rest of the class in Slack. So that's basically how we're going to use it in this class. So threading is kind of the main thing, to have conversations about like one individual assignment or project that you're sharing or idea or thought. And then beyond that, you can do lots of other things like adding emoticons and whatnot. There's different like add-ons you could add to this. um, so there's lots of different add-ons you could add to this. I added a Giphy add-on where you can do / Giphy and then say like, I don't know, school. And then I'll give you random GIFs that you can kind of use. And then if once you see one you like that's appropriate for whatever we're talking about, then you can send it. So that's kind of a fun thing to do too. Okay, so that's Slack. Do you guys have any questions about Slack? Make sense? Okay, cool. All right, so let's go ahead and jump into the lecture. Let's see what's the best way to do this. Okay. Okay, you guys see that okay?
Yeah.
All right. Okay, cool. Okay. So last week we just generally talked about physical computing, what it is, and this week we're just going to get into like the basics of what electronics are and circuitry and electricity, since that's basically what we're going to be playing with for the entire semester. So we're just going to talk about the basics. We're not going to go too deep into it. And feel free to just interrupt me if you guys have any questions or add it to this to the Zoom chat if you guys have any questions. Okay, so electricity. So electricity is basically just a flow of electrical energy through conductive metals. Usually that's like copper or aluminum or something similar, some sort of metal. But technically any organic material is also conductive. So like our bodies, plants can also conduct a smaller amount of electrical current. So there's two different types of current when it comes to electrical flow. So there's DC, which is direct current, which flows in just one direction. So at the bottom, you can see how it's visualized. So DC is just flowing in one direction. And AC, which is alternating current, is a direction of current flows in reversed in a regular repeating cycle. So it goes from positive to negative, kind of, if you visualize it like that. So that's the difference between DC and AC. And DC current is usually a lower voltage, so it's safer to work with, versus AC current, which is powering like your refrigerator and washing machine and whatnot, is much more powerful, and that's more dangerous to work with. So for the projects that we're going to be working on, we're going to be using just, for the most part, DC current. So an electrical circuit. So an electrical circuit is made up of at least two elements: a power source, like a battery or an outlet, and components that convert that electrical energy to other forms of energy, like light or heat, or kinetic or moving energy. Connected by a highly conductive material like copper or aluminum. So that's the basic circuit design that we the most basic circuit design that we could play with. So here's just a very simple sketch. You have a battery at the bottom, which is the electrical power source, some sort of conductive wire that's probably made out of copper or aluminum or a mix of metals like that. And then some sort of component that's taking that electrical current and that load, like a light bulb, and then using that to turn on a light or turn a motor or have something else happen based off of the electrical current flowing through it. So you can kind of think of this as like a circuit, like a car circuit, just racing around this path, going from point A to point B and then back again, and just constantly moving. So that's kind of a good analogy when it comes to electrical circuits. So there's also some things that could definitely go wrong with your circuit. One would be a short circuit. So short circuit is basically when there is a power source and the load bearing component, whether that's a light bulb or something else that's taking that electricity, is bypassed. And it's basically just going from the battery back to the negative side of the battery. Then this wire here is just going to get like super hot because it has no other place to expel that energy. So because of that, it's going to get really hot and then either catch on fire or catch something else on fire. So you just have to be careful with short circuits where you're basically doing just a loop that doesn't have a load attached to it like this. So if this green wire wasn't there, then it would be fine. The LED would be taking that current and turning on and using it, versus just this wire has nothing to output that energy. So it just gets really hot. So it just gets really hot and then could catch on fire. So we're going to be working with a number of different sensors. Sensors are basically just components that can convert other forms of energy into electrical energy. So we can take that data, take those readings and change them into other forms. So a sensor would be like a proximity sensor, a distance sensor, would basically be taking that, it's basically creating some sort of like currents or creating electrical energy based off of how close you are to it. And that changes based off if you're really close or far away. So we could take that reading of the electrical currents from that and then apply it to something like the arm of a motor or something. So it changes from one direction to another. Here are some sensors. So some of the basic ones would be just buttons, which are called momentary switches. Then there's toggle switches. Potentiometers are basically just knobs. And then light sensors take the amount of light that it sees in any environment and then translates that into like a current, basically. And then we could take that current and see how bright it is or how dark it is in that particular area. So on top of our sensors, we have actuators, which are basically components that convert electrical energy into other forms. So those can be servo motors, DC motors, or LEDs. These are just some examples. There's definitely others out there too. So these are taking a current from whatever source, whether it's a battery or the Arduino, or one of the sensors that we have attached to it, and then using that current to like change the direction of the motor, change the speed of the motor, change the brightness of the LED, etc. And then we have some other components that you might be working with this semester. Capacitors are similar to batteries. They can hold a charge for just a short period of time and then expel it. Diodes are mainly used to make sure that the current is flowing in just one direction. LEDs, or the little lights, are technically diodes as well. Then there's H bridges, which are a little bit more complex. There's relay switches, which allow you to control AC power from your little Arduino. And then resistors are basically, we're going to talk a little bit about them in a minute, but resistors help you change the amount of current that's flowing through your circuit so you don't overpower any components that are attached to it. Then there's also 5-volt voltage regulators, which take the voltage or current that's coming into it and then outputs a 5-volt voltage. There's transistors, there's power connectors, etc. Okay, so any questions so far? Hey, Tony, welcome. Okay, so far so good? Okay. So the next thing I want to talk about is polarity. So some components have polarity, meaning that they have a positive and a negative side. So they only work in one direction versus the other. So some of those components would be LEDs, so the lights, the diodes, which basically control the current from one direction to another. And then some capacitors, some usually smaller capacitors, have a polarity on it. Generally, to indicate polarity, one leg is longer than the other, and usually that means, at least for LEDs, the longer leg means positive, has to be connected to the positive side, and then the shorter leg has to be connected to the negative side. And every power source has a positive and negative flow. The other thing that you should be aware of is that all of these components, regardless of where they come from, should have a data sheet attached to it that you can kind of look at and look at the diagram and see how it's put together, how it's made, what voltage and current it can handle, if it's has polarity to it, how big it is. So all this information is helpful when building projects that are using all of these components. When it comes to building circuits, there's really two different kinds of ways of building it. There's circuits that are running in parallel, and then circuits that are running in series. So parallel is basically saying we have a positive side is connected to one component and then also the other component. And then the negative side is connected to each other and then to the negative side of the power source. So this is running in parallel. So the great thing about running something in parallel is that, like, if this connection is broken, then this will still work, and vice versa. For the running a circuit in series, if for some reason this connection is broken, then the whole circuit will break. So it really depends on what you're building to determine whether it should be created and designed in parallel or in series. But these are kind of the two options that you have to work with. The other thing that you're probably going to come across is electronics schematics and circuit schematics. And basically that's just a diagram that is showing you what's happening with the circuit. So this little icon is basically saying that this is a switch. So it's whether that's a toggle switch like a button or sorry, a momentary switch like a button or a toggle switch or something else. That's unclear, but this is going to be a switch, so an on and off. This little squiggly line is going to be a resistor, I believe. And this icon represents a LED. And this icon represents a power source. So those are schematics, kind of breaks down what the circuit is doing and an easy way to kind of visualize it. Okay, so for just a very high level look at what electricity is, there's three different things that you really need to have a basic understanding of. There's voltage, which measures the difference in electrical potential energy between 2 points in a circuit, which is represented by volts. Current is measurement of the magnitude of flow of the electrons, which are amps. And then resistance is the measurement of materials' ability to oppose the flow of the electricity. So it kind of squeezes out the amount of current that could flow through it. And those are represented by ohms. This all gets really confusing for me, so don't be intimidated by this. It takes time to kind of wrap your head around it, and you'll get there in the next couple weeks, I'm sure. So I like to visualize this too. So voltage is kind of pushing the current through. Current is represented by amps. And then ohms, or the resistors, are resisting the amount of currents that can flow through the circuit. So the voltage is pushing the current, the amperage through, and then the ohms or resistors are resisting the amounts that can go through. And there's lots of different types of resistors depending on how much current you want flowing through your circuit. So this is kind of visualized in this graphic. There's a lot of other ways to kind of visualize it. This is another visualization showing a mountain range, and kind of the height of the mountain is the voltage. The current is like boulders falling down the mountain, and the resistance would be anything in the boulder's way, like trees, to kind of slow down the current. There's a video kind of demonstrating this too. So the current is the liquid flowing through the circuit. The resistance is, this is I think some like mesh or something that's resisting the amount of liquid that can go through it. And then the output is just kind of lesser amounts, or not as strong as a flow. And then the voltage would be the power supply or the pump that's pumping the water through the circuit. So any questions about voltage, currents, and resistance? Okay. So here's another example. It's kind of just a more fun example, using roller derby as a analogy. So let me just play this real quick. All right. So yeah, so I like to show as many visualizations of how the circuit works, and because it is hard for me to kind of wrap my head around it, so I'm sure anyone coming into this fresh, it's a little challenging. So I think visualizations and diagrams help with that. So hopefully that was helpful. So yeah, so the next thing I want to talk about are resistors. So resistors are basically used to control the amount of current that goes through your circuit. So if you don't want to like fry a component like an LED or a motor that can only handle so much current, then you have to figure out what the right resistor is to use in that circuit. So these are resistors. And all of the resistors have some lines on it, and those lines represent values essentially. So how many ohms this resistor can handle or output essentially. So for this one, if you look on the right-hand side, this is kind of a chart that helps you determine what colors represent how many ohms, how much resistance essentially. So if it's red, brown, and then gold. So red is 2, brown is 1 times 10. So that would be, and then gold is just the kind of tolerance. I rarely kind of look at the last bit, but it's still important, but probably not as important for this class. So this would be a 2 times 10, which is 220 ohm resistor. So we're actually going to use this one in the demo today. So if you wanted to find that in your kit and follow along, you're welcome to. But yeah, so this is a 220 ohm resistor. So there is also a great website that makes this a lot easier to, it's basically a calculator for resistors. So you basically just kind of click on what the first color is, which is 2, second color, which is 2, red, and then the third, brown, which is 10, which is a multiplier. So 22 times 10 is 220 ohms. So yeah, so this is a great resource for you too when working with resistors. So any questions about resistors?
Not at the moment.
Okay. Yeah, again, you'll kind of get more of a hang of it once you're starting to use them and kind of work with some of the examples that came in your Arduino kit. So this is just kind of like an overview of electronics in general and the different components that you have to work with. Okay, so the next thing I want to talk about is the digital multimeter. So this is a great tool for you guys to have in your toolbox. I normally have these in the classroom for you guys to use, but since we are not going to be meeting in person, unfortunately, I won't be able to share all of that with you. So if you can purchase this, then I would suggest getting it, but it's not required. You can kind of work around it. It's just going to make your life a little bit easier, and it's a lot easier to like troubleshoot and bug fix with the digital multimeter. Okay, so this is kind of the general makeup of a multimeter. So we have the V over here stands for AC voltage, which you're probably never going to use, definitely never going to use in this class. We can measure the amount of AC voltage for any power source. This A and the line with the dots underneath it represents current. So you can measure the amount of current or amps in your circuit. This icon here is for continuity. So basically, if you want to see if your circuit is connected, you can turn it to this little icon, and when you touch the circuit with the multimeter, with the positive and negative sides of the multimeter, it'll make a sound if it's a complete circuit. If it's not making a sound, then the circuit's not complete, or it's broken somewhere. You could also measure resistance. So if you wanted to measure the resistance of any resistor, so so if you don't want to read like the color lines on the resistor and determine what the resistance is, you can also measure it with the digital multimeter. And then you could also measure the amount of voltage for DC power supplies. So the V with the line and the dots underneath represents DC voltage. So you can measure like batteries and whatnot. So here we have the voltage and COM channel, and this is what we are going to be using for this class because we're only working with DC current. So this is kind of like the negative and the positive. So you touch the black to the negative or the minus on a battery, and the red would be the positive, essentially. So continuity, here I could show you this in real time. Okay. All right, so this is my multimeter, and it has these leads plugged into it, which is basically just a big cable. One's black, one's white, and on the other side, we have these kind of like metal pronged things. So these are what you're going to be touching to like a battery to measure the voltage, or a resistor to measure the amount of ohms or resistance that it handles. And then for changing, like if you want to test continuity, you turn it to that icon that kind of looks like a speaker / LED icon there. And then when you touch these two together, it should beep. So if you do this on a circuit, and if the circuit is connected properly, then it should beep as well. So this is just a good way to determine if the circuit has continuity, is fully connected somewhere, everywhere. Okay. So that's the continuity. And like I just demonstrated, this is how you kind of test it to see if it's working. If you hear a sound, then you know it's working. And then if you want to test voltage, you can do that as well. So we're just going to deal with DC current. So you want to make sure that it's turned to the V with the line, straight line, and the dots underneath it, not the V with the squiggly line that represents AC. This one represents DC current. So if you wanted to measure like the voltage coming out of a battery, like a 9-volt battery, you just change the multimeter to like 20 volts. So this is like a range. So if the battery supply is going to be between like 0 and 20 voltage, then you want to turn it to 20. If it's going to be less than that, then it's like 2000 milli or 200 milli. And then anything larger would be turning it to a higher voltage value. So I have a battery here. So this is a 9-volt battery. And I'm going to turn my multimeter to 20 volts DC. And then when let me see if I could switch my camera, hold on. So this is set to 20 volts DC. And if I touch the battery, let me see if I can put this in the screen. So if I touch the negative side with the black and the positive side with the red, it should say around 9 volts. So it says 9.37 volts. So that is correct. So this is a 9-volt battery. It's never 100% precise, so it's never going to say like 9.00. Just electrical engineering is never really that precise, but it's okay. Okay. Okay, so you can also measure resistors to measure the ohms using a digital multimeter. So you can measure the resistance in a resistor, or you can measure the resistance in variable resistors, which are basically the knobs, or they're also called potentiometers or pots. So let's go ahead and try that too. Okay. So I have my digital multimeter here. I don't know why it's upside down. There we go. Let's try that. So I have my digital multimeter, and then if I wanted to measure the resistance of this little resistor, then I can just set that down here on the side. Change this to ohms. So let's do, let's try 200. Yeah, let's try that first. See what happens. Okay.
I have a question.
Yeah.
The one I have at home, it says, no, that says AC. No, because I was trying to figure out, like, I have one, it's like I kind of have a clamp, see, on my end, and then it's like digital. So it doesn't have like the 20 or the numbers. I think I have to manually put it in.
Really? Can you hold it up to the screen so I can see it?
So this is the one I have. Oh, hold on. Let me take off my background. Okay. So that's the one I have. So I was trying to read the thing and it says like, but it only says for AC.
Really?
So AC current from 0.00A to 400A, that?
Okay. It's possible that it's just for AC current.
No, but it has a thing for DC.
It does?
Yeah, but I don't know how to change
it. So does it have the icon with the V and like the straight line and the dots?
Yeah, it does.
Okay. So I would try that. Just turn it to get like a 9-volt battery. Turn it to like the 20-volt option or like within that range. Anything like above 9 volts, essentially, that's not too huge of a value. And then test it to see if you get the value from that.
Okay.
So yeah, so this one, I was just getting 1 when I had it on 200 ohms, which meant it's probably too low of an option. So I changed it to 2K ohms. And then I'm getting, yeah, about 216. So again, it kind of fluctuates depending on how the connection is, but it's around 220, which is the right amount of resistance for this resistor. So that one's accurate. Okay, cool. Okay. All right, so measuring current for these, this is going to be for, so measuring current, yeah, so you can turn it to the amperage over here. And that'll give you the amount of current that is coming from a voltage source. But we're not going to test that, but because that could potentially fry out your digital multimeter, depending on if it's too powerful, too much of a current flowing through your multimeter. So let's kind of skip over that. Okay, so Ohm's law is kind of the only equation that really matters when it comes to circuit design and electricity. And it's basically just voltage equals current times resistance. So if you wanted to get the amount of voltage, then it's current times resistance. So you always need at least two values here to get the third. So voltage equals current times resistance. So voltage you can think of as like the battery. Current could be like the component that you're using and the amount of current that it can handle. And resistance is a resistor that you're using in your circuit. So if I'm using a 9-volt battery and my LED, my component can only handle 11.5 milliamps, which is 0.0115 amps, then the resistance, we could figure out the resistance with this equation. So it'd be 9 divided by 0.0115, which is about 780 ohms. So knowing that, then we know what resistor to use for a circuit that has a 9-volt battery attached to an LED, a light that can only handle 0.0115 amps. So that would be a 780, or about a 780 ohm resistor. So yeah, so that's and to determine the amount of current that any component can handle, that's when you want to look at the data sheet too, because it'll say on there like a range of the current that particular component can handle. Sometimes you could go a little bit over, and it's not a big deal. If you go too far over and give it too much of a current, then it'll just kind of burn out and fizzle, and then it just will destroy that component. So that's the only potential issue that could happen, and then eventually it could like short circuit. So you just want to be careful of that. But with LEDs, I think a range between like 300 and 700 ohms for a resistor is probably fine for a 9-volt battery, or like powering from the Arduino itself, which is 5 volts output. Okay, so that's kind of the basics of voltage, currents, and resistance, and just kind of general 101 crash course in electricity. Any questions about any of that? Or using a multimeter?
Yeah, I think with mine, it was just like it does it automatically or something.
Oh, really? So you got you tested it?
Well, I didn't have a battery, but I was reading the manual.
Okay, yeah, that's fine. You could also test like the amount of voltage coming out of the Arduino, because once you plug it in, the output should be 5 volts, so you can see if that's actually true. Okay. So the other thing that you're probably going to be using a lot is the breadboard, which came with your kit. And a breadboard is just a really easy way for you to prototype a circuit. And all you have to do is take the leads of any component, whether that's an LED or a resistor, and then kind of plug it into these holes on the breadboard. And essentially underneath all this is this. So it's just lines of conductive material, which is probably like aluminum or copper or a mix of something. So these lines are on the side are usually used for like power rails. So that's where you usually plug in your like battery or your Arduino to power the circuit. And then you can use these rails to power your components from the side. And it's good to do it from both sides as well. So I normally, let's see if I have an example here. Let me just take this apart. Okay, so I normally do something like this. Hold on 2 seconds. Okay, so I normally do something like this with my breadboard. So I attach the positive sides together with like a red piece of wire here. And then I attach the negative sides together. And then when I attach my voltage from either battery or the Arduino to any one of these rails, and then also kind of the ground side, which is black, back to the Arduino, then this rail will get power and this rail will get power every time I plug it into the Arduino. So that's why it's connected here. So I can use either side for power and ground, essentially. So that's just kind of a good technique when setting up your breadboard. Okay, so that's the breadboard. Any questions about that? So again, these are going to be your power rails. So that's where you're going to plug in your power and ground cables. And then these are going to be your component rails. So all of your like LEDs and buttons and motors are going to be plugged into this, and then probably plugged into the power rails to get power as well, or directly into the Arduino itself. Okay, but again, we'll talk about that more next week. So yeah, so this is how I would set it up. So connect the ground sides together. So as long as like the blue or whatever color this is on yours is connected to the other blue, that's fine. Then red is normally representing power. So connect the red to the red side. And now if you plug in a battery or your Arduino into this side, so power is red again. So all of this is going to be powered. And then because this is connected over here, all of this is going to be powered too. And because this ground is plugged in on this side, all of that's going to be connected to that. And then also because this is plugged into the other side, the other rail is going to be connected too. So that means you can use this side and this side for both power and ground. Does that make sense? Okay. Hopefully y'all are awake still. So here's a very simple circuit. So this is using an LED as our component. And you can see that the longer lead is plugged into this rail, which is then plugged into ground. And then the power is going through this 220 ohm resistor, which is then powering the LED. So actually, why don't I quickly kind of show that to you as an example. Let me get an LED. Hopefully it's a working one. Okay.
I probably missed this, but for the LED, do you always need a resistor? Like, how do you know that you have to use one again?
So it depends on your power source, and yeah, it depends on your power source. So if it's a low power source, and then the LED could probably handle it. But if it's like 9 volts or higher, then you probably need some sort of resistor in between. And that's when you would use Ohm's law to determine what resistor you would use. But again, for LEDs, as long as you use something that's like, I don't know, between 300 and like 700 ohms, then that's probably fine for anything between like 5 or 9 volts. If you don't use one, it's not the end of the world, but your LED might get fried and then it's just kind of dead and doesn't work anymore. So for this example, I'm going to be using a 220 ohm resistor for this little red LED. Okay. So for LEDs, let's see, I believe the shorter side, so all LEDs have like a long lead and a short lead. And I believe the short side is for ground and the long side is for power. So we just have to make sure that that is plugged in to ground and power. So the top side is going to be power and the bottom side is going to be ground. And then I'm going to be using this 9-volt battery and this 9-volt battery connector. So this might be good for you guys to have too. I don't think it comes in your kit if you're doing anything that's powered by anything other than the Arduino. You might need to get this, but it's basically just plugs into the 9-volt battery, and then on the other side there's these open little leads here that you can plug into the breadboard. So I'm going to plug this one into ground and this one into power. And let's leave it unplugged for right now. And then I need to get wire. Let's see. Okay, so these little jumper cables came in your kit as well. These guys. So these are basically just little cables that we could use to plug in and connect the circuit. So I'm just going to use one for ground for this circuit. And let's see if this turns on. Yeah, there we go. Okay, so now it's plugged in, LED turns on, it's getting power. If I disconnect any of this, then it's disconnected. So this is kind of like a switch, just taking out one of the cables, one of the jumper cables, and then putting it back in. It's kind of like an on-off switch. So I'm basically breaking the circuit and then reconnecting it. Cool. So I have my power, the red cable running along this red power side, and then black is ground, which is connected to the battery. And then the power, the red part, is running through this resistor, this 220 ohm resistor, which is then connected to the power side of the LED, which is I believe the longer side. Yeah, the longer side. And then the shorter side is connected to this cable, which is then connected to the ground, which is the black rail here. So that's a completed circuit and going back to the battery. So if anything comes off, then the circuit's broken, and then you have to reconnect it to turn it back on. So that's basically what the circuit that I showed in the diagram is showing. And This is really hard to see on the video, but the diagram is really helpful. So when doing this, I would suggest looking at the diagram for a reference. The one thing that you have to remember is that this LED has to be on two separate rails. So that's why the long side is on what? These are all numbered too. So the long side is on 18 and the short side is on 16. If they were on the same rail, then that wouldn't work because the positive side and negative side are on the same rail. So those sides have to be separated. Cool. All right.
You said each row was like positive, negative?
It depends on how the power is flowing from the battery. But for this example, the positive side is plugged into where the resistor is here, and then the row below it is the negative side. It's kind of hard to see, but this like black line is connecting that bit over there. So as long as these aren't on these two leads aren't on the same row, that's really the only thing that matters. They have to be on separate rows. Otherwise, there's no break in between the circuit running through both leads. So that's why you have to separate the positive and negative side onto separate rows. So let's take a look at some other examples. So this is another example that's basically kind of doing the same thing, except it's connecting this with this. Based off of what you guys saw in the breadboard, do you think this circuit would work? Is this a complete circuit?
It needs more wire, right? Between the red and the resistor.
Yeah, so this isn't connected to that. So because of that, this is just kind of empty here and broken. So the circuit isn't complete. So you'd have to basically just add a wire in between here and here, and that would complete the circuit. Because these columns and rows and these columns and rows are separated by this middle section, you have to connect it there to complete the circuit. What about this one, this example? Think that would work?
Well, you said they can't be on the same line, right?
Right.
But since it's separated, would it work then?
Yeah. So technically, yes, it's on the same row, but because there's a gap here, it's not the current isn't flowing to both of these at the same time. So this would definitely work because of the gap here. So yeah, so that would work. What about this one?
So this one wouldn't because there's well on the same line.
Right. Yeah. That is true. So because they're on the same row and there's no break in between the positive and negative side, it wouldn't turn on. So here's just an example of different ways of creating the two different types of circuits, the parallel and series. So if you wanted to have multiple LEDs turning on with the same power source, this is a circuit in series. So it's getting power from the power source and then going to both the LED's power source because they're on the same line. Same thing with the ground and negative. Those two are both on the same line. So they both would turn on. So that wouldn't be an issue. The only problem with a series is that the amount of current that runs from this one to this one, I think is going to get cut in half. So I think the green might get less current and less power than the red. So this green might not be as bright, or it might like divide it evenly, so they both might be kind of dimmer. But because there's also two LEDs in here, you probably don't need a resistor or as strong as a resistor, because the amount of current is being divided between the two. So this is an example of a circuit in parallel. So for this, because they are basically separated and not on the same kind of circuit area, it's getting the same amount of voltage that was before. So you need to continue to use the same resistor. And they should be at the same brightness too. The other good thing is that like if you take this LED out, it won't break the circuit. This one will still work. Versus the other one, it should still work because of how it's set up. Yeah, sometimes it won't always work for series. Okay. So that's also just so you're aware, this little line here isn't a piece of wire. That's just showing that it should be connected, but you don't need another piece of wire here connecting to the resistor. And the same thing with our with the LED. You don't need another wire here. It's just the only way I could visualize it. So this is just the two leads plugged into different rows. And then here's just an example of a switch. So this switch is just plugged in here. This should come in your kit. It has two sides on it too. That's why I kind of straddled the middle. But we're only using one side in this example. But this switch is connected to power. And then the switch is then connected to the resistor, which is then connected to the LED, which is then connected to ground. So if you press the switch, then it should open up the connection and turn on the LED. If you release it, then it'll break the connection and turn off the LED. It's basically the same thing I was doing by like pulling the wire out and then putting it back. And then just so you can see like how a diagram compares to what it looks like on a breadboard, this is a circuit board diagram for this particular circuit. So you have a switch, you have a resistor, you have an LED, and you have the power source. Here's another example that's using, you should have a potentiometer or like a knob in your kit too. And those are basically they're called variable resistors. So as you turn the knob, it's going to change the resistance and the amount of current that can flow through the circuit on a variable level. So as you turn it, it's going to increase or decrease the amount of resistance that can pass through it, which is going to basically dim or brighten the LED attached to it. And here we have the potentiometer connected to both power and ground, which on one side, and then the other side is connected to the resistor, which is then connected to the LED, which is then connected to ground. And here is a schematic showing what's going on here. So we have the power source, we have the variable resistor, we have the resistor, and then we have the LED attached to the resistor. And then all of them are going to ground. So this icon represents ground. So just so you're aware, if you're curious, the piece of software I use for creating these diagrams is called Fritzing. It's a free piece of software that you can use to kind of put this together. So if you wanted to kind of do this yourself and kind of diagram out and sketch out your circuits before you actually put them together, then you can do that using this program as well. It's pretty great. There's like a library of different components that you can kind of click and drag, and then it snaps to different areas for you. So this is a pretty great tool. Okay. All right. So any questions so far? Okay. So here's what I want you to do. Basically, I want you to make your own switch playing around with an LED and a power source. So that power source can be a 9-volt battery. It could be your Arduino itself. It could be potentially any other battery. But I basically want you to play around with coming up with creative ways to make switches. One thing to think about is what's conductive, what can conduct electricity. So you can think of playing around with like aluminum foil, metal like rods, or one student was doing a project with metal chopsticks that conducted electricity. So what can pass a current, and then make like some sort of interesting switch to turn on the LED. So that could be like, I don't know, wearing, taping aluminum foil and wires to your hands. And when you clap your hands, it'll turn on the LED. Some people have made like little channels out of 2 pieces of aluminum foil, and then has like a metal ball, and then you roll the ball through the channel and it turns on the LED. I've seen people use salad bowls and like metal salad tossers, and when you kind of put the metal salad tosser in the bowl, it'll turn on the LED. So kind of think about creative ways to make interesting switches rather than just using the switch that came in your kit. And then based off of what you put together, write a blog post about it. And ideally throw up like video and images and really document your creative switch. Another one would be someone opening and closing a door, and that connection between the door lock and the like metal bit attached to it would be a good one. So yeah, I'm just trying to like throw some out there just so you have a general idea of what I'm looking for. Yeah, so that's kind of what I'm thinking.
And it has to be so yeah, anything with an LED, but then our own creative spin on it versus a boring switch.
Yeah. So just a creative, interesting switch, which is basically just at its core having two wires connect to complete the circuit. That's essentially a switch, but kind of play around with that concept and come up with interesting ways and kind of explore your apartment, explore your house to see what's conductive, how you can use things in your house or like found on the street, or in your kitchen cabinet somewhere, to make a creative switch. Okay. Any questions? Does anyone want me to demo anything else?
Professor, I have a question.
Yeah.
So does this have to be like fully functioning, or is it like a prototype like the first assignment?
It has to be functioning enough to turn on an LED. So you have to have a power source, whether that's a 9-volt battery or using your Arduino.
Okay.
But yes, the LED has to turn on when you do something to complete a connection.
Okay, thank you.
Yeah. Any other questions? I'm happy to like demo other stuff too if you guys wanted to see anything. Okay, well, I'll just quickly show you just 2 wires connecting, and this is basically like on a very basic level, this is what I'm looking for you to do, but in a more creative way. So Okay. So here I have my power source. So I have a battery. You could do this with the Arduino too. If you just plug the Arduino in to your computer, that gives you power from your computer. And then you can plug in the 5-volt output for the power source, and then ground for the negative. So for this example, I have one wire here, one wire here. And when I touch those together, it completes the circuit. So that's a switch. So if I attach like one of these wires to some aluminum foil, and same thing with the other one, just like tape it down. It's not going to be the most secure thing in the world, but it should work for enough for you to take a video of it, and then attach it to something else. Or if you have like electrical wire lying around your house somewhere, like an old, I don't know, like lamp where you could cut the cord or something like that, you can use that as to elongate the cable. But that's essentially all I want you to do, but have a creative way of making that connection together. Let me see if I could try and do this with the Arduino too, just so you can see that working as well. So I'm just gonna plug the Arduino into my computer. And give it power. Okay. And then the Arduino has a 5-volt output here and a ground input there. So I'm just going to, let's switch this, plug in the 5 volts to the power source here. And then the ground to ground here. And hopefully it'll work. The resistor might be too big, but let's see if it turns on. Okay, so it turns on a little bit. So this is 5 volts instead of 9 volts, but it still works. So I'm using the 5-volt output for the power here and the ground input for ground here for the same connection.
So if you took out the resistor, it would still be fine, right?
If I took out the resistor, it would break the connections, and we would have to make that connection here somehow. But I can try and show you what it looks like without the resistor. It might be like super bright, might burn it out, but it's okay. So if I plug in just a piece of wire here. So this is connected to power. That was hard to plug these in. Okay, one. There we go. Okay, so this is without the resistor. Yeah, still turns on. Seems okay. So if you use the Arduino, I don't know if you need a resistor since it's the current's low and the voltage is fairly low. But it's still, I mean, it can't hurt. So I play around with that too. So this is just using the Arduino to power the circuit rather than the battery. Cool.
I have one last question.
Yeah.
Are we gonna get any like student examples posted to Slack that we can
Student
see
examples of
this project?
project?
Yeah.
I can share some. I usually try not to, just so I don't want you to get swayed in one like direction or another. I want you to like think of it creatively without being swayed by other projects. But if that's helpful, I can post some.
Okay, thank you.
Sure. Any other questions?
And so if we want to make it larger, we just use a larger wire, right? To the breadboard, like connecting it.
Yeah. So if you want to extend it, then you need to get longer wire. So unfortunately, what comes in the kit is pretty limited. So if you have like wire lying around or like old lamps or something lying around, you can use the wire in there. But you'd have to like strip the wire, so it gets a little complicated. But yeah, I guess you would have to strip wire regardless if you had like bought it too. So yeah, I guess what you could do is if you wanted to, you can use aluminum foil and like make like a tube or something and like roll it up and use that. And might it might lose some of its like flow of the current because of like how thick it is or long it is, and just because it's just rolled up aluminum foil. But I think that would be fun to experiment with. So yeah, the project is really a way for you guys to experiment with conductive materials, and play around with circuits in an interesting way. So get creative with it. If you don't want to buy anything, that's fine. Just look around your house and see what you can work with. And yeah, aluminum foil is a really good way to a conductive material to play around with, and everyone has that in their kitchen. Your parents might not appreciate you using it all, but they'll understand, I'm sure, if it's for school. So yeah, so just kind of play around with it. Think about what's conductive. If you have a digital multimeter, then you could use that to test conductivity. So if you turn it to the connectivity option, yeah. Let's see. So if you turn this to the connective option, which is like looks like a little LED diode and like a speaker kind of thing, or mine kind of looks like a Wi-Fi connection icon. And if you touch these together, it should make a sound. Then you can kind of go around your house and touch different things that's like metal and seems conductive. Nothing is beeping for me, so oh, there we go. So yeah, I got something that's conductive. It's like a clamp that's holding up my camera. I thought my wrenches would be conductive, but they're not. Sometimes there's like a coating on top of the metal that loses the conductivity. Yeah, so if you have a digital multimeter, that's a really great tool to see if something is able to conduct electricity or not, just by touching it with these two leads. And then it should beep if it's conductive or not. Okay, cool. Any other questions?
Yeah, I had asked in the chat, but just really quickly, where can we purchase extra wire, like a hardware store?
Oh yeah, so I added some links on the class website for, I think if you go to, let me see. So if you go to class website.
Oh yeah, I see it under like all the tools. It's an Amazon link. Cool.
Yeah. Let's see, I think it's under helpful links. Yeah. So there's 22 gauge solid wire. You want to make sure that you get the solid wire, because sometimes this like the threaded wire, which are hard to put into the breadboard. So yeah, this is what I have and what I recommend. You could probably find that at the hardware store or something similar. Just make sure that it's solid wire. So you can see in the picture that it's like solid over there. So yeah, you could probably find this at Home Depot or Lowe's or your local hardware store. You can get on Amazon, it'll come in like a day or two. But yeah, this is what I recommend.
Awesome. Thank you.
Sure. All right. Any other questions? Let's see. Yeah, two power sources to make it stronger. I think you can add multiple, like put a series of power sources together. I'm not sure if it'll up the voltage or not. But I think it should. I don't know. I'll test that out. I'm kind of curious. I'll put two 9-volt batteries together and see what happens, and let you know.
Mine doesn't beep when I put it together.
Really? Are you? Is the settings correct?
I don't know. I probably have to look into that. Ugh, maybe I'll just end up buying the one you have because it wasn't that pricey anyway.
No, they're not that expensive. If you hold it up, can you hold it up again? So I can
Oh, I turned it off. So I was like just playing around with it, but I don't know. I just put it on the DC.
Oh, so it's I can see the icon. It's like four up. It looks like a triangle with two lines. Triangle on top of a cross kind of thing.
That one?
Yeah, that one.
Yeah, I had that one on earlier too. And still nothing.
Sometimes make sure that like you like press down on where it's connected. Sometimes the connection is bad at the bottom. And then try it again.
0.
Nothing.
Yeah, when I put them together, it just goes to 0.
Oh, really?
Yeah.
That's weird.
I don't know.
It should make a sound.
Oh. Well.
Yeah, I mean, yeah, the one that I recommend that I use in class isn't expensive. So if you want to just buy that one, that might be worth the couple of bucks to throw at it.
If this one was just laying around the house, it's like, oh, okay.
No, it's great. I'm sorry. It should work. I'm kind of curious. I want to like, I wish I was like close by to like look at it and play around with it and try and figure it out. It might just be old and like maybe that part isn't working.
Mm.
So Kevin, so you're asking about did I add that device to the site? Do you mean the digital multimeter to the site? If so, that there is a link to where you can purchase that too. And then the soldering iron, that's not required for what you guys are doing, but it might make things easier depending on what you're building. So a soldering iron is basically allows you to more permanently make connections. So you could solder, like one really good example would be like if you had a box and your components were, or your Arduino was inside the box and you had LEDs and like buttons on top of the box, there's going to be like a like 5-inch gap in between the components and the Arduino in the box, most likely. So one good thing to do is to like solder longer wires to your components. So you have longer leads to plug into the breadboard and the Arduino. So that's one example that you would use solder to extend the leads of your components so you can kind of make bigger things essentially. There's also things called wire wrapping tools where you can wrap the wire around the components, but that's kind of finicky and not as permanent, and the connection can break pretty easily. So, so yeah, again, I don't think you need to buy a soldering iron now, but it's something, depending on your projects and what you're building, it's something that you might want to buy in the future. Cool. All right, any other questions? All right, and also, again, this is the first time that I'm teaching this remotely, so if there's anything that would make this easier for you guys or help you out, or there's more demos or more diagrams or more whatever, please let me know, and I'll make those modifications and alterations to the class and to the syllabus. So yeah, feedback is helpful. It's encouraged, so I appreciate it.
I got the buttons beeping.
You got what?
And now it beeps now.
Hey, it's awesome.
This is annoying. You have to press this button, then press that button.
Oh, really?
Yeah, it says you have to press the hold button, and then you have to press the max button, then you have to press the select button to make sure you're on the right thing.
Oh my God, why is that so complicated? It should be like one step. That's weird. But yeah, great. Glad it's working now. So you can run around your house and see if like what's conductive. Okay, so okay, so that's the project I want you guys to work on this week and today. So finish up that project of playing around with a switch and making a creative switch out of it, and post what you create on the blog. I also want you to read Tom Igo's Physical Computing's Greatest Hits and Misses. The link can be found on the class website. And then lastly, just kind of look through your, So lastly, I'm curious for you guys to look around at all the sensors you interact with on a daily basis. So that could be like a motion sensor to get into a building to open a door. Could be like a key fob you use to get into your apartment building. So I mainly just want you to be aware of the sensors that you interact with on a regular basis, and just make a note of all of them, and how you interact with them, how often you interact with them, and based off of that, do a blog post on all the different types of sensors that you interact with on a regular basis. So that could be anything from like the remote control to watch TV, the keyboard you're using to type messages in Slack, your mouse, your camera, your phone. So I just basically want you to be more aware of your surroundings and the sensors that you work with on a regular basis. And then, yeah, do a blog post based off of that. Cool. All right. Any questions before we take off?
Yes, Professor. So next week we don't have class?
Next week, let me check my calendar. No, the next 2 weeks are weird with like holidays and whatnot. So
Yeah, I don't even know which class.
so yeah, next week we do have class. The following week we don't have class.
Okay, got it. I got it confused.
Next week, Tuesday and Wednesday, the college is closed, but Thursday we're open again. And then the following week, it's Wednesday and Thursday, the college is closed. So I'm not seeing my Wednesday class for 2 weeks, which is really weird, but how it works.
Okay,
So yeah, so we are meeting next week, but the following week we're not.
got it.
Okay, cool. All right, any other questions, thoughts, comments, queries?
Nope, sounds good.
Okay, so the creative switch is due next week, so it's kind of in class / homework assignment, so you got time to work on it. And then when we meet next week, I want you guys to again first do the greeting in Slack and say hi for attendance, and then I want you to post your blog post for that switch and the blog post for the just sensor observations. So then we're gonna just do the same thing. We're gonna go through them as a class, add our comments as a thread, and check them out. Yeah, so the object again for the creative switch is just make a switch, which is basically just connecting two wires together to complete the circuit. So I would start there, to be honest, just get the setup working and just connecting two wires together to make sure that's working, that the light turns on, and then go beyond that and kind of come up with a creative way to make that connection, whether it's like metal salads tongs in a metal bowl and you kind of put the tongs in the bowl to make the connection and turn on the light. Or playing around with like aluminum foil or anything else that's conductive in your house or apartment to make that connection and turn on the light. So the object is to turn on the light in a creative way, essentially. I don't know, no worries. Okay, cool. So yeah, so that's again all I have for you today. So feel free to spend the rest of your time, class time, playing around with the switch idea, or just do it on your free time. It's fine. But yeah, any other questions before we head out? Okay. So yeah, like I said earlier, feedback is really helpful. So let me know if anything from today's lecture was confusing, or if you like one thing better than the other, like if you like real-time examples, demos of me putting together circuits, or if you prefer just like the diagrams. Yeah, so any feedback you can provide is helpful. I will export this video. Hopefully I didn't mess it up. This is the first time I tried it. But I'll export the video and post it on our class website probably sometime this evening. So it should be available to you there. Okay. So it's a good thing I'm recording this because it sounds like there's a lot of technical issues. And hopefully it worked. Okay, so yeah, that's all I have for you guys today. Feel free to reach out over the course of the week on Slack or email me if you have any questions or want any help with anything, or have any comments or feedback on today's class. Yeah, I'm available to help, so just let me know. Cool.
Thank you, Professor.
Thank you guys.
Have a good week.
Thank you.
See you. Take care.
See you next week.